All right, everyone. So today we are going to be doing notes on section 2.5, which is all about compound inequalities. So go ahead and pause this real quick and write down the definition and the first example. All right, so compound inequalities. This just means that you have two inequalities that are joined by the word and or. So what you just finished taking your quiz on is when you're just dealing with one statement, one inequality. But now we're going to have two statements. So we're just going to do a couple of basic graphs first to see the difference between the and or graphs, and then we'll get into some examples where we actually have to solve. So the first one, graph x is less than 8 or x is greater than or equal to 10. All right, so I'm going to graph both of these separately, and I'm going to do it in two separate colors so that you're able to see the difference between the two lines. So the first one, x is less than 8. Will that be an open or closed circle? Good. This will be an open circle because it is less than. Remember, less than or greater than is an open circle. So I'm going to put an open circle at 8. And it's all the values less than 8. Everything smaller than 8, which is everything going to the left. And remember, if you have the fun little trick, your variable is on the left-hand side. So this is like an arrow pointing to the left. Your arrow is pointing to the left. All right, now let's look at x is greater than or equal to 10. Will that be open or closed? Good, this will be closed. So at 10, that will be a closed circle. And it's greater than or equal to. So it's everything greater or bigger than 10, which is everything to the right. Actually, I'll go ahead and label these above the graph as well, just in case you're only using one color for this, so that you know which one is which. So I want to point out for this, for the or statement, the arrows go away from each other. Second example we're going to look at is now an and statement, and I'll explain why I did two separate number lines in just a minute, but let's go ahead and graph these. Open or closed? Good, this is closed. Closed circle, so we're going to have a closed circle at -5. And it's everything greater than or equal, so all numbers that are bigger than -5, which is everything going to the right. And again, I'll label these in case you're only using one color. Then x is less than or equal to 7 will also be closed. So now I'm going to put a dot at 7, closed dot, and it's everything less than or equal to, so everything smaller than 7, which is going to be everything going to the left. Now, the cool thing about these and statements is our final answer is where they overlap. So if I look at this, right here, this section, that's only the green. And this section here is only the blue. I want to look at where the two sections overlap, which is here, everything between -5 and 7, and on both ends is a closed circle. So my final answer is going to be a closed circle at -5, a closed circle at +7, and it is everything in between. So this is the graph for x is greater than or equal to -5 and x is less than or equal to 7. So the and graph is connected. Now I want to point out the other way that you could view this answer is like this. This is saying x is literally written in between -5 and 7. And my graph, my final answer graph, is literally in between -5 and 7. So I'll get into what this form looks like when we do actual examples where we're solving for our variable before we graph our answer. Go ahead and take a second to pause this and write down our next example. So now we're going to be doing an OR statement, but notice I have not solved for x yet. I have two statements that need to be solved for x first. So this is why we did just a single inequality that you took the quiz on today. That's why we've been doing that for the last few class sessions, because now you're going to have to combine all that knowledge to solve these compound inequalities. I will do this one with you, and then you're going to solve this one on your own. All right, so first thing I do here is subtract 3 from both sides. So I get 4x is less than -8. And then divide both sides by 4. And I divided by a positive number, so my inequality stays the same. So I got x is less than -2. Now go ahead and pause this video, solve this one, and then push play when you're ready to check. All right, go ahead and check your answer. You should have gotten that x is greater than 3. Now, for those of you whose inequality is wrong, just a reminder, when you multiply or divide both sides by a negative number, you have to flip the sign. That's why this is now greater than. So I'm going to write my final answer, which is x is less than -2 or x is greater than 3. I want to make sure I rewrite that with the word or in between, because that was our original problem that we started with. We've just solved for x in both inequalities now. By the magical powers of video recording, I now have a number line that has appeared, and I want to graph this. So, open circle at -2, and it's all the values less than -2. So everything smaller than -2 is going to the left, or if you use the trick with the inequality sign, the x is on the left-hand side. The variable is on the left, so we can do that. Or this is also going to be an open circle at 3, and it's all the values greater than 3 or bigger than 3, which is everything to the right. So this is my final answer. I'm going to go ahead and highlight this so that you know it's part of the answer. I realize now that I didn't highlight these graphs up here, so I went ahead and highlighted my graphs that were the final answers. Next example, we are going to solve and graph this thing. So this is an and statement. Whenever it is an or, it will always explicitly say the word or. So this right here, this form, where we have two inequalities, our variable is stuck in the middle, this is the compound inequality for an and statement. So I'm just going to put a little note. This is an and inequality. All right, now there's two ways of solving this. You can either, get another color pen, you can either separate them into two separate inequalities or keep them together and solve it. So I'm going to go ahead and write that note. I personally prefer to keep it together as one, but I'm going to show you both methods so that you can decide which one you like the best. So you can separate them, or keep it together to solve. So let's go ahead and show you both methods. Sorry for the kind of weird lighting. The sun is setting and it's how the light comes through the window. All right, so let's look at the first one. I'm going to separate it. Because you've seen solving two separate inequalities. Now, when you separate this, you have to look at it as this part, so the left side, the negative 4 is less than x minus 5. And the right side, the x minus 5 is less than or equal to negative 1. Now I'm going to solve these two statements separately. I'm going to add 5 to both sides. So I get 1 is less than x, but then I'm going to rewrite that so that the variable is first. Now this inequality opens with the big side towards the x, so it stays open with the big side towards the x. Then for the other one, add 5 to both sides. And that one is just x is less than or equal to 4. So I'm going to rewrite this as x is greater than 1 and x is less than or equal to 4. Now when I graph this, there's my magically appearing number lines again. I'm going to graph this as two separate statements. So I'm going to have x is greater than 1. So put my open circle at 1. Greater than is everything bigger, so everything to the right. And then x is less than or equal to 4. So a closed circle at 4, and it's everything less than that, which is everything to the left, everything smaller. And my final answer is where they overlap. So my final answer is here, where the blue and green lines overlap. So I have the open circle at 1, the closed circle at 4, and it's everything where the blue and green overlaps, which is everything between those two numbers. This is our final answer. And that. All right, now let's look at how we solve this when we keep it together. So keep together. So instead of separating this into two separate inequalities, I'm going to leave it as the negative 4 over there. I'm just going to recopy this exactly as it's written. Now, when I solve this, I want to get this x in the middle by itself. So if I add 5 in the middle to get rid of it and make the x by itself, I need to do the same thing to everything to keep it balanced. I need to also add 5 to the left and add 5 to the right. So I'm going to put a little note. Do the same thing to the left, right, and middle. This keeps your inequality balanced. Think of it like these are 3 scales and you want to keep them all equal. I just realized it's hard to tell because my hands were the wrong direction. So if these are your scales, if you only add 5 to one side, only one side is going to change. You need to keep it so that they stay the same. So this is negative 1. Your inequality stays the same. X, inequality stays the same. 4. Now, before I graph this, when I look at this, x is literally between, ooh, that was close to the edge, -1 and 4. So when I graph this, I'm going to go ahead and do my number line. And notice I don't put tons of numbers. I just do the numbers I need, 1 and 4, and then one number on either side, on the outside edges. So when I graph this, -1, that's an open circle because the -1 is connected by the less than. So that's an open circle. The 4 is connected with the or equal to. So the 4 gets a closed circle. X is literally between -1 and 4. So on my graph, it's everything literally in between -1 and 4. Exact same answers, but two different ways to do it. Now, my personal preference is to keep them together. This is how I will do it on homework questions. This is how I'll do it in notes. This is how I will always solve it. I will keep it together as one inequality. The other difficult part about separating them is there's a lot of room for error when you change your inequality signs around. Plus, all of your answers on quizzes and tests are going to be written like this. So if you separate them, you need to be able to look at this and understand it's the same as this. Both of these things that are highlighted mean the same thing. Let's look at one more example where we're actually going to solve and graph this. So this is another AND statement, but now notice there's a lot more stuff going on the inside. We have this -3 that's being multiplied as well as the 1 that's being added. So we're going to solve this just like we were looking at it with just one inequality. You subtract the 1 first, then divide by -3. The only difference is now we're doing it to the left, middle, and right. So I'm going to subtract 1 from the middle, from the left, and the right. Keep it balanced. So then I have 6 is less than -3x is less than or equal to 12. Now I need to divide everything by -3. Middle, left, right. Now this is where it gets a little bit tricky, and you have to be careful. 6 divided by -3 is -2. The middle is just x, and the right, 12 divided by -3 is -4. But when you divide by a negative, what do you have to do? Good, you should have said that you have to flip. So both of these inequalities are going to flip the other direction. Both of them flip. Now, writing the answer like this, notice -2 is on the left, -4 is on the right. We want this to be written so that it's in order from left to right, smallest to biggest. Right now, it's not. So I need to rewrite this with the -4 on the left, x stays in the middle, -2 on the right. But I need to make sure my inequalities stay going the correct direction. So the x and the -2, the big side opens towards the -2. It stays opening towards the -2. The x and the -4, the big side opens, the big side of the inequality opens towards the x, so it stays opening towards the x. Now I need to graph this. At -4, connected to x, it's an or equal to, which means it will be a closed circle at -4. At -2, it's connected to x with a non or equal to, which means it's going to be an open circle. And remember, this means x is between -4 and -2, which means on my graph, x is between -4 and -2. Last example I want you to look at, go ahead and pause this and write it down. You're going to be trying 2 of these on your own. Given the graph, write a compound inequality that represents it. So I give you a graph for part A and part B. You need to determine if it's an and or an or statement, and then write the actual inequality. Let me actually underline these. So what I want you to do right now is go ahead and pause the video and answer both of these questions. Push play when you're ready to check. Go ahead and check your answers. You should have said that part A was an or statement and part B was an and statement. And both of these have one of them that is just a greater than or less than symbol, and one that has the or equal to line. So double check and make sure you have that right. Now, something that I want to point out with these and statements, these inequalities, when it's written as this compound statement with the 2 inequalities, these inequalities always go the same direction. Always, 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 always. If you ever write your final answer where these are not going the same direction, you did something wrong and you need to go back and double check your answer and your work, because they should always, 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 always be the same direction. All right, that is the end of your notes. Have a good rest of your day.